I think there's so much scope with this still, and people aren't really scratching the surface yet with designing for additive. That's a big area that people are starting to look at, so it's taking an actual part and redesigning it for the process, really utilising it to its advantages there in that instance.
We've travelled to the Car Fulham Group and we're really trying to find out today where Stratasys are with 3D printing and the future, because honestly, it's blown my mind, this has, Rob, what you're capable of producing now.
That's it. I think, Stratasys have come a long way in terms of what our offerings include now. We've got 5 different technologies that we talk about. The parts that we've got in front of us here are specifically from the PolyJet technology, and so you'll see a lot of colour parts, as you can see here, assemblies that we've created, rubber parts and overmoulded components. There's just such a broad range you can achieve with the PolyJet technology.
We will look through all of these and I'll just ask you a few questions on these, but who is really, where are we with 3D printing? Because it was something that we talked about in the future. You can have, obviously, people can have 3D printers in their homes, but you're the kind of industrial professional end of the marketplace. So who is buying these machines?
It's a multitude of companies, everything from a one-man band all the way through to your OEMs. And I think, it comes down to the application that the person's got, depending on what they're doing, from everything from design through to production. We do have a solution to fit. That throws up its own challenges, of course, because, where do I sit in the range there? There's printers out in the market for £500 and there's printers out there for £500,000, So I think that's where we come in. We pride ourselves on a consultancy. We can help people to understand how we can fit one of the technologies to the application, and then within that range of technology that we've got, as I say, under the 5 banners, we can pick the right solution as well to fit.
I mean, you've been talking about making parts for the Airbus, A350. We've been talking about making jigs and fixtures in the metal cutting industry. Like, where does it end and where does it begin?
I think there's so much scope with this still, and people aren't really scratching the surface yet with designing for additive. That's a big area that people are starting to look at, so it's taking an actual part and redesigning it for the process, really utilising it to its advantages there in that instance.
We often go out to a lot of companies and it's all subtractive machining, and now this is additive and it's growing a lot. What are people's reservations on the materials?
I think that's the case, again, depending on the sector you're talking to at the time. If it's in design, a lot of people are used to getting prototypes made. They're used to getting 3D printed parts made by a service bureau and things like that. And that's where we'd maybe be looking at a technology like PolyJet there to satisfy that requirement. You'll be saving money by producing the parts in-house. You've got a range of different materials you can do that. When it comes to the more engineering sort of end of the spectrum, where people are a little bit more dubious about 3D printing in some instances, they sometimes think that they've got to be at the sort of end of the spectrum where they're printing end-use parts. It doesn't need to be that. It can be shop floor aids, it can be jigs and fixtures, it can be CMM fixtures, soft jaws for their machine tool, and actually be an additional asset to the business on the shop floor rather than something that you're going to actually sell the parts off.
And a lot of your printers are literally for the shop floor. It's not to have in a separate room or anything like that. It's literally, you can put this next to my machine tool and be saving your time, even on the metrology side of things as well.
Absolutely, yeah. All of our machines very easily operated and can be put on the shop floor alongside a machine tool, or even in the office in some instances. We've got to say such a broad range. It depends on what people's setup is.
I just want to quickly cover some of these, because these are this will really kind of float your boat and excite you. Here, I can't push this. This is a really solid material. It's the same material though, isn't it?
That's it, yeah, all acrylic based.
And then this one here, you can see how soft they are. Here you've got different finishes, marble, woods. Here you've got a finish of kind of like something like you'd get in your car, a leather finish. You've got a material that actually spins around. I can't do that with my hand, but that literally spins, and that's printed in one.
That's right. So I mean, one of the things that we can do is we can use the support material to support any gaps in the part. We can wash that away with water. We have a water-soluble support material now for this range of technology here, which just allows you to put the part into fresh water, and it just dissolves that support away, giving you moving parts like that.
So what would you say to anyone then? I know SYS sells Stratasys, solely Stratasys machines. What would you say if someone was having reservations or thought, could I maybe look into the world of 3D printing? I mean, look, this banana, this banana itself, like everything on this table pretty much has been 3D printed. It's incredible.
That's right. I think at the moment what I'd say to people is just come to us, challenge us, have a chat with us about the application that you're thinking about, and it don't have to be a full colour application.
No.
It can be something, as I say, on the shop floor where you're thinking, I've got a bottleneck here with metrology or assembly fixtures, things like that, and there may be a technology that we've got that can fit, and I think that's where we can really help people out.